means putting a building onto it. So down on AHD, or our survey, we see that we have a building. Now I'm not going to pay too much attention to the floor level because this is a timber frame floor, which means that it's sitting above the ground. I want to, in this case, assume that it is a concrete slab, meaning that it's going to get cut into the site, because that'll give us a better result for what I'm trying to show you. So we're going to place a slab. Now I'm just going to use a cover fill, just so you can see that I place a slab, and then we'll have a look at how that works. That's okay. So what we're going to do is draw that slab, and I'm going to just define it using the polygonal method, just so it is the size of the outline of this building. Now it's a pretty complicated shape with the bay windows, but it's fine. So we don't need to be perfect. Just trace it a bit. Double click to finish. Oops, that was terrible. There we go. So that we got the outline of the building. Now we've created a slab. I used a cover fill just so you could see that it is a slab. We're going to cut that. I'm using Command X on my Mac, and I'm going to go up to the ground floor and I'm going to paste it. Now it's very important that I pasted this object at 0 to my ground floor. Now, how do I get this right? If we go down to the AHD, we see that this floor level is sitting on, it's not one for the carport, unfortunately, around about 322 meters, 890 or 850. So there's 40 mil difference from front to back, which is pretty scary, but that's what happens in old houses. Now, we want to work that out, but in reality, we need to understand that we need to add this much height to our next story. So if we want our floor level to be at a height of, let's say, the height level of this point here, 322 meters, we'll use this one. So we're cutting into the site just because it's going to be better for what I'm trying to show you. Then we need to go into our story settings and make sure the elevation of our ground floor is 322 meters, which is not at the moment, is it? So we're going to make AHD 0, which means our terrain starts at 0 because it's just for reference. And then we're going to add into our height to next. Now it's very important that we do it this way. Trying to type into the elevation just makes it very difficult. It always is better to type into height to next. 322,000, 322 meters from terrain to our ground floor. Seems like a long way, but that's because it's really high up. Our slab is still sitting at 0 to this story, but most importantly, it's now sitting at 322 to our entire project, which means if I'm dimensioning, these are using real AHD, Australian Height Datum dimensions. Now, when I look at this in 3D, ta-da! What we see is our slab, without having to do any other magic tricks, is sitting into the site. In some places, it's slightly hovering above the site, but mostly it's actually cut into the site. Yep. So in real life, a slab could be doing this, but normally, in a real life situation, we would have had to excavate that site first. We would have had to dig it out. Now on a site like this, we could completely excavate, or we could do cut and fill, where we're cutting part of the site and filling part of the site to try to get the slab sitting at a median height, or we could build up the entire site, so filling the entire site. Now filling is another matter altogether. I'm going to show you how to do cutting or excavating using a slab into a mesh. And this is using our solid element operation tool. So to do that, we go to Design, Solid Element Operation. We select, doesn't matter which order, but we're going to currently select our mesh, and that's going to be to get cut. We're going to select our slab, and that's going to be our operator because it's cutting the slab or the mesh. Then the option that we want is subtraction with upwards extrusion. Look at the little coloured shapes. We're wanting to use the slab, which is the red, to cut away up at the blue, which is the mesh. subtract with upwards extrusion, and then press execute. What this is going to do is to cut away and cut into the slab. So we see that we've got excavation. Now the clever thing about this is it's in a relationship. So this could either, if I was to then reduce the height of this slab, let's say minus 1,000, minus 1,000, it's going to sink that slab further into the mesh. It's still going to cut it, the relationship is going to be maintained, and wherever the slab moves, the mesh will have to adjust to it. Or, of course, if we moved it up, plus 1,000, there would no longer be a relationship, and the mesh would now be solid again. Let's move that back to 0 where we want it, and so we see that it's now cutting. So of course, if this is a carport or a garage at the front, we can't have a big step, so we need to build something else like a ramp. And to use a ramp, we might use something like a roof. So let's just quickly do that just to explain what we're trying to achieve. So let's just get the roof tool really quick. We're going to do the single plane roof tool. We're going to first define the orientation, and then we're going to define the shape, and we're going to make, let's say, the ramped section of this driveway about 4 meters. That's alright, I did something wrong. There we go, I did it on the wrong story, that's fine. Let's move it up to ground floor. Continue. Let's go into the settings. We want to make sure that the ramp is at 0, and in fact we want to make sure that this ramp is only, say, 100 mil thick, and we want it to be, or even 1 mil thick. Let's just turn it into concrete, maybe. Take the cover fill off because that looks a bit silly. And we should be able to see it now back on this story. Yep. So now let's view this in 3D. Clearly too steep. Maybe we want it to be 5 degrees. It's not cutting back through the mesh, so it needs to be a bit steeper. Of course, we could define this graphically as well by picking up a corner point and moving the Z height. Now this is a very clever tool. See how the line of the roof is currently dashed, and when I lift it out of the ground, that line becomes solid. So that's, even before I finish it, it's defining where the relationship is. Yeah. So I'm going to have that sitting slightly out of, slightly in the slab, and I'm going to again use that solid element operation tool just to explain it, that it can work for other objects as well. Design, solid element operation, the ramp or the roof or my driveway is our operator, the mesh is our target, subtract with upwards extrusion, execute, and then we've now cut a ramp into our side as well. Yep. So we can use this for construction or for landscaping, and it's a very good visual representation of how our building will fit on the site. So if we go to the effort of drawing the terrain mesh properly, it's going to give us really good interactive feedback as to how you should be positioning your building on site. Of course, the reason for this is that if I was trying to get this building to be flat on site, we'd see that we'd need to fill it over here a bit. Let's just make this a bit deeper. Let's make it 600 or 900, just so we can see that we have a bit of depth over here where we're sticking out of the ground, and here we have depth where we're cutting into the ground. That would therefore mean there's a decent amount of excavation to be done on site. Now, if that was simple, sandy, maybe clay soil, it would be a different matter to if this was a hard stone bedrock that we're cutting into. And in terms of a design consideration, we want to consider